Okay, here we go, guys. This is a recap of the quiz we just took, so sections 1 through 4, topic 5. Okay, so the first thing you need to realize is what the derivative is. We can ask for it several different ways. You can have f prime of x, dy over dx, y prime, df over dx. Those all mean finding the derivative, okay? What the derivative is just a fancy way of asking what is the slope at that particular point. Okay, so here we've got our original function, right, with someone skiing along, or I guess walking as well. Anyway, so here we've got a point at 1 comma, I don't know, whatever, 1. Okay, so if that point is on our original function, okay, so f of 1 equals 1, right? The x value is here, the y value is there. But on the derivative function, okay, so for the derivative function, so f prime of 1, all right, because this is at 1, what is the slope at that point? Well, the slope is a small negative number, okay? Derivative is a slope. So this is a negative slope, and it's probably something small, all right? So it's a negative number. Negative number. All right, let's see. Let's look at some other points on it. Okay, what about this point right here? All right, so that point is 4 comma, I don't know, let's just say it's 4 comma 5. So at the point when x is 4, y is 5. All right, but if I were to take the derivative at 4, the derivative at 4, well, the slope at this point is 0. Okay? I'm just asking what the slope is. So the derivative, f prime, is what's the slope at that particular point. Okay? But if I were to do, let's say, this point right here, okay, on the original function, it is f of 3 comma, I don't know, let's just say, what do we want to call it, 2? So when x is 3, y is 2, kind of make it look reasonable. All right, our derivative, so the derivative when x is 3, so the slope when x is 3 is a positive number. Okay, notice how that one's increasing. So this is a positive number. Okay, so let's find exact ways how to find that number, that slope. Okay, oh, I'm sorry, forgot that I had this in here. So this is another way to visualize it, okay? So you can go back and forth this way. This is your original function, so in blue, it's the original, and the purple is f prime of x, that's the derivative. So if a function is increasing, if the derivative is positive, well, think about what f prime of x, that's the slope. When the slope is positive, more than 0, when it's positive, the function's increasing. Well, yeah, because think about it. If I have a positive, if I have a positive slope, see how I'm increasing here, right? My derivative at those same x values should all be positive. And notice they're all positive. Okay, let's go here to g of x. Notice I'm increasing along this part, increasing along that part, and both sections of the graph, see that part is over 0, and the part over here is all over 0, because all the y's are 0. I'm sorry, all the y's are positive. I'm going to keep explaining that. Okay, so this part is increasing of h of x. Okay, that part's increasing. So the same x values on my derivative have to be above 0 because it's a positive slope. Again, these values right here are increasing, positive slope. All right, so the same x values over here are going to be above 0. All those values in the same portion are just y is above 0. Okay, we can look at the negative part. So in f of x, this one is decreasing. So the derivative is going to be below 0. Here, the derivative is decreasing. So my derivative is below the x-axis. Derivative decreasing, below x-axis. Decreasing, below x-axis. Okay? So, that's what I'm trying to get you guys to see. All right, now what if we look at just the turning point? So where the yellow and the green meet. So we've got a turning point there. Well, notice the turning point is where it hit the x-axis. Turning point here, both of them are on the x-axis, on the derivative. All right, h of x has 3 turning points. So it's going to have 3 zeros on the derivative. This one has 1 turning point. Okay, so actually it's hard to see. Those are open circles. It should be right there. Sorry, the graph's gotten a little blurry. Okay, so here, let's see. This is all negative. This is all positive. Oh, actually, no, not all negative and positive. What am I saying? This is decreasing. It's going down, right? It's kind of keeps going down. This one is also decreasing, going down. So that's why all my values are below the x-axis. The whole thing is decreasing. Okay? This one is at a steady value. It's because it's linear. So it's got a steady value underneath. Okay? That slope does not change. This slope is never changing, but it is positive. So the derivative, the graph, the slope is steady. It's constant. Okay, because this slope was steady. It was constant. These slopes change. Okay, so my graph of my derivative kind of adjusts for that. They're more of a curve. I know this one's kind of hard to see, but if you zoomed out, this would be more of a curve. Okay, because we have a much steeper slope here than we do here. Okay, so hopefully that part makes sense. Let's just do the algebra. Okay, so we want to find the derivative and the gradient where x is 2. So let's start with the derivative. So we do the power rule. So the derivative of number 1 is just going to be, you take the exponent, put it out front, and you take 1 less than the exponent. So the derivative is 12x cubed, and we want to find it when x is 2. So we're going to find when x is 2. So we do our exponents first. We multiply. There we go. So the gradient of the point where x is 2. So the slope when x is 2 is 96. Okay, again, we do the power rule for number 2. So the derivative would be 3 times 5, x to the third minus 1. So we get the derivative to be 15x squared. We want to find it when x is 2. So we do 15 times 2 squared. So 15 times 4. So we get 60. So the slope of at this equation when x is 2 is slope of 60. So very, very steep slope. Okay? Number 3. We find the derivative. We do the same thing for each one of these. Okay? So we're going to get 2 times 2x 2 minus 1. the 3x, so that's 3x to the first, so it'd be 1 times 3 to the x, 1 minus 1. And then for the negative 5, we're going to treat that as negative 5 times x to the 0. So it would be negative 0 times 5x to the 0 minus 1. Which I know that was a lot, even though we just know we're going to multiply by 0, so this part just goes away. So the derivative of a constant, a number, is just 0. So here we get 4x to the first plus 3x to the 0. Alright, so now we want to find our derivative. Well, we can simplify that. I'll try and show all my steps, I know. We don't need to put the 1 as an exponent. You can if you want. And anything to the 0 is just 1, so 3 times 1 is 3. Find it when x is 2. 4 times 2 plus 3, so 8 plus 3. Our derivative when x is 2 is 11. Okay, these are the slopes at that point, at when x is 2. At some point 2 comma y on our graph. Alright, let's do some more. So again, we want to find the derivatives and the point when x is 2. So, number 4, we take the derivative. So here we're going to get 3x squared plus 2. And in this one, it's it's a constant, so the derivative is nothing. So our derivative is just this. So our derivative at x is 2 is going to be 3 times 2 squared plus 2. So what is that? 4, 12 plus 2, so 14. 14 for that one. For 5, alright, maybe the division messes you up, so let's just fix that. So we get y equals 2 times x to the negative 1 plus x to the first. So the derivative is just going to be negative 2 x to the negative 2. I told you I would show all my steps, and I don't know if everybody's got this negative part, so we're just going to write it out. So again, negative 1 times 2x to the negative 1 minus 1. Move it out front, take 1 less. X to the first, move it out front, take 1 less. So again, that's the derivative, is negative 2x to the negative 2 plus 1. I'm going to find it when x is 2. Don't really know what I was writing there. Alright, so we get negative 2. I don't like it as an exponent of negative 2, so I'm going to go ahead and move that x squared on the bottom and make that like this. I just didn't like that negative exponent, so I just put it back on the denominator. So then we get negative 2 over 4 plus 1, so it's that negative 1/2, so we just get 1/2. Okay? I just solved it, that's all I did. So number 6, we can rewrite this as y equals 3x to the negative 2. So the derivative is negative 6x to the negative 3. Or we can write that as negative 6 over x cubed. So our derivative when x is 2 is negative 6 over 2 cubed. So negative 6 over 8. So negative 3/4 is our slope. Okay? Now let's go and find, we're going to sketch the function and its derivative on the same axis and say whether the function is increasing or decreasing at the point where x equals 2. Okay, so we want to write down the range of values for x, which the function is increasing. Okay, so first you want to sketch it, so get out your calculator. Okay, so let's start with the very first thing it asks us to do. Sketch the function and its derivative on the same axis. So this is the original function, so our derivative function should just be 4x plus 3. All right, so now get out your graphing calculator and put in the y equals for each of them. I already have it, so 2x squared plus 3x plus 5, and the y prime is my second one. So as you can see, both the equal signs are highlighted or kind of darkened. That says that they're going to be on the graph. When it's empty, like y3 to y7, nothing will show up for those. On the left side, those colors, okay, tell me, we'll let you know which one. So the blue one is my original, the red one is my derivative. So then I hit graph, and it takes a little while. I've already done mine. So here you can see the derivative, and blue is the original function. So we want to know whether the function is increasing or decreasing at the point where x equals 2. So when x is 2, so if I just trace them, I'm on my original one, the blue. So when x is 2, oh, did I not hit trace? It's because I hit the button. That's what it is. Trace 2. Hold on. Okay, sorry. Didn't realize what I was pressing. Okay, so trace. Then it says plot. I want to be on the graph. So when it says y equals with x's and y's. So here, now I'm on my graph. So then I hit 2. And I'm at 9. Okay, so that's just my regular point, but I want to know what the derivative is, so why don't I get on my red line? So now I'm on my red line, so at the point 2, it's at 11. It's a little off my graph, of course, but the slope is 11. Don't put it into the original graph, okay? So is it increasing? Well, on the blue graph, on anything on that right side, so at 2, yeah, it's increasing. So my slope should be positive, which makes sense for it to be 11. Okay, so it is increasing at the point where x equals 2. Okay, and we want to write down the range of values of x for which the function is increasing. So there's two ways we can go about this. Okay, we can either find the minimum point of our original equation, so of the blue, so finding that minimum, that's the turning point. So finding that turning point, all the slope on the right hand side is going to be positive, so increasing. Or we can find where the derivative is just greater than 0. So when, let's see, here we can have where it hits the x-axis, because here on the red line is the derivative. We want the derivative to be bigger than 0, so we want it bigger than where it hits the x-axis. Okay, so we can trace and find things. So second trace, we can find the minimum if we want to use the blue function, or we can find the intersection if we want to find where it the derivative intersects the x-axis. Okay, either way you can find it that way. I like to do it algebraically, so I want to find it when the derivative is equal to 0. Okay, so that finds my turning points. So 0 equals 4x plus 3, so we get x equals negative 3/4. So at that point, at x equals negative 3/4, it's either going to increase or decrease. So think about I said that wrong. At negative 3/4, it's either going to be a minimum or maximum. So think about your x-axis. You have negative 3/4. The first integer to the left would be negative 1. The first integer to the right would be 0. So we know negative 3/4 is 0. So that's a turning point, a min or max. Okay, now we need to figure out which one. So here, looking at our graph, it helps us. So at x equals negative 3/4, we're here, it's a minimum because the left side is decreasing. So if you look on your graph, this side is decreasing, and the 0, or the part on the right hand side, is increasing. so it should be a minimum. Okay, so here we've got a minimum, so it's increasing everything to the right. So the range of values where the function's increasing is going to go from everything bigger, so x is everything bigger than negative 3/4. Okay, let's do another one. Okay, so here we want to find if it's increasing or decreasing at the same value, and we're doing this function. So I want to find the derivative as well. So another way of writing this function is 2x to the negative 1 plus x. So the derivative is negative 2x to the negative 2 plus 1. All right, so put those in your graph. By graph, I mean your graphing calculator. Okay, so you graphed those. So you've got the original as blue and my derivative as red. When we graph that, all right, again, we want to find out if it's increasing or decreasing when x is 2. So just so I can visually see it, I'm going to trace along my blue graph where x is 2. So I'm right there. This one I can tell it's increasing because that's on a positive line right there. So I know it's increasing. Okay, we want to now find the range of values for which the derivative is increasing. It helps to know the turning points. So you can either find the minimum or maximum using your trace function on the blue graph, or we can use our red line and find the intersection of the x-axis, so the zeros there, or we can do it by hand. Okay, so let's see, we want to find the derivative, so when the turning point, so that when that is 0, so when the derivative is 0, so 0 equals negative 2 over x squared plus 1. So I'm going to make that 2 over x squared equals 1. So we get 2 equals x squared. So x can either be, hopefully you remember this, positive or negative. We put the square root there. So we have two values, square root of 2 or negative square root of 2. And let's see, looking at our graph, okay, square root of negative 2 is here. A positive square root of 2 should be right there. Okay, I'm pointing at it with on the blue. And yeah, so negative 2 squared, negative square root of 2 should be right around there. That maximum point right there. So let's see, here we have negative square root of 2, square root of 2, you have 0 somewhere, negative 2, positive 2. So looking at that, the left side of at square root of 2, here, so you can actually see. Let's plug in the square root of 2. Where's my square root button? Oh, there it is. Being silly. Square root of 2. Okay, sorry, I meant to put negative, but it's fine. We'll start on the right side. So square root of 2 there. To the right of it, that's all increasing. Okay. Oh, I should probably do a different color. Don't mess you up. So this slope is increasing. The slope at square root of 2, these are turning points, so it's at 0. Our left of that, it's going to be negative. Okay, so I know that's going to be decreasing right there. But if we switch over and do the negative square root of 2, all right, notice to the right of that, it's also decreasing. So this is all decreasing. It might look a little weird in there, but I'm not really concerned. I just know that this whole part is all negative. Okay, they're all downward slopes, negative slopes. Then here, to the left of it, it's a positive. So it's going to go like this. So we have, this is a maximum, and at square root of 2 is a minimum. Okay, so it's going to be increasing on this interval and this interval. So everywhere where x is less than negative square root of 2, and where x is greater than square root of 2. Okay, so this part is for B. Okay, so if I want to find the normal or the tangent line, okay, so my purple is my original graph, okay, and I've got some point on that graph, on that purple graph, and I find the slope. That helps me with the tangent line. The slope at that point is also the slope of the tangent line. So if we have A over B for that, then the normal is perpendicular. Okay, so it's negative B over A. It has opposite reciprocal slopes. So find the derivative of this equation. All right, so the derivative should just be, we're doing the power rule, so negative 0.04 x to the first plus 3.4. Find the gradient of the tangent at the point where x is 50. So the slope when x is 50. Okay, tangent is the same slope. Okay, so we need to plug in here, let's see, the derivative when it's 50. So we do negative 0.04 times 50 plus 3.4. We get out our calculator. Alright, so we plug that in and we should get 1.4. So remember, that represents the slope of the tangent line. Okay? Then we want to find when find f of x when x is 50. So we put that into our original equation. So 50 in the original one should look like this. Again, we're plugging it into the original function. So when we plug that into our calculator, we get 120. This is how I'm showing my work when I use my calculator. This is what I'm plugging in. This is my output. So now that represents a point on my graph. When I plug in x is 50, the y is 120. So I've got a point, and I've got a slope. That's all I need to find the tangent line. Tangent means it's using the slope of that equation, or slope at that point, and that point. So let's plug it into our equation. Y minus 120 equals 1.4 x minus 50. Point slope form. So the equation ends up being, what is that? 1.4 times 50, 70. Okay, so we get y equals 1.4x minus, well, we got to add the 120, so it's going to be plus 50. So that's your equation of the tangent line. That's how you find a tangent line. Find the slope at that point and find the x and the y at that point. Plug it into point slope formula. Okay, so now let's do it for a normal. So we want to find the equation of the normal. So let's start by finding the tangent. Okay, so first thing, we're going to need a point, right? So we know when x is 1, so let's find the y value. So we're plugging in 1 into our original equation, and we're going to get, what, 2 plus 3 minus 2, so just 3. So now that means the point 1, 3 is on all of our graphs, on the original equation, on your tangent line, and your normal line. Okay, remember, too far. This point right here. Okay, it's going to be on everything. So now we want to find the tangent line. So let's do the derivative. So we get 6x squared plus 3. And we want to find the derivative when x is 1. So we can find the slope. So 6 times 1 squared plus 3 ends up with 9. So we have our slope, and our point. So plug it into point slope form. Okay. Oh wait, I'm sorry. That was for the tangent. For the tangent. But we wanted to find the normal. Okay, so the normal, we take that original slope and we change it. We do the opposite reciprocal. So now our equation should be y minus 3 equals negative 1/9 x minus 1. We're still using the same point, but now we have our slope is opposite reciprocal. So don't do the tangent line if it's asking for the normal, like I almost did. Okay? Now if you want to have to put it in slope-intercept form, which makes my life easier, let's see. We're going to move everything over. Negative 1/9 x plus 1/9 plus 3. So I don't like the 3, so I'm going to rewrite that as 27/9. So we get y equals negative 1/9 x, what is that, plus 28/9. There's the equation of our tangent line. Okay, I believe that's right. Let's keep it rolling. The gradient of the normal to the curve with equation that at the point 1 comma b is negative 4. So now, whoa, things are getting weird. Okay, let's take it one step at a time. The gradient of the normal to the curve with the equation at the point blah blah is that. Okay, the gradient of the normal is that. So the gradient of the tangent must equal the opposite. So instead of negative, it's positive 1/4, so positive 4/1. Okay, that's handy to know, because if we take our original equation and we find the derivative, that should be 3k x squared minus 2. Okay, I know that the derivative at this point, when x is 1, that my slope must be 4. So if I plug in f prime of 1, I should also get that equal to 4. So now we can solve. So k equals 2. Again, I took the derivative of this equation, and I know that the derivative is just the slope at that point, at x equals 1, but it has to be the opposite reciprocal because that was normal. I wanted the tangent. So it's just knowing how the words are related, okay? I can't stress that enough. All right, so we found the value of k. Well, now we need to find the value of b. So b is just our y value. So use that into our equation. So we've got f of x is our original equation. K is now 2. And we want to find it when x is 1. So 2 times 1 cubed minus 2 times 1 plus 1. So we end up with 2 minus 2 plus 1. So when we plug in 1, we actually get out 1. Coincidence, I know. So the value of b is 1. All right, again, that was coincidence. Notice how I found it. I plugged it in. Okay, so that wraps up the main parts of just finding the derivative, the gradient, finding the tangent line and the normal line. Okay, hopefully that makes sense. If not, you know where to find me.